Hi there, this is Miss Mouton, and today we are going to talk about quadrilaterals. So our quadrilaterals are a part of a larger family of shapes, our polygons. A polygon is a shape that has flat surfaces and angles. It is a planar figure, which means that it has no depth, no thickness. If you were to turn it sideways like a sheet of paper, you couldn't even see it. It would disappear altogether. We're going to focus on our four-sided polygons in today's notes. Please follow along in your notes template. The first quadrilateral we're going to talk about is our parallelogram. Emphasis on that portion of the word parallel. So a parallelogram is made up of two sets of parallel sides. Opposite angles are congruent, so that means they are the same, and it has at least two pairs of congruent sides and two pairs of parallel sides. Generally, our traditional parallelograms are made up of two acute angles and two obtuse angles, but we're going to look at in just a bit how we can classify other quadrilaterals as parallelograms. Really, the only characteristics or the only things they have to have are two pairs of congruent parallel sides. So if your brains are churning and you can think of other quadrilaterals or shapes that have four sides that have opposite sides congruent and opposite sides parallel, they can also be classified as parallelograms. And I'm sure that as we go on in our notes, you'll be able to call other shapes parallelograms as well. But here's our traditional parallelogram. Traditionally, they have opposite acute angles that are congruent to each other and opposite obtuse angles. That is not always the case. So in your notes template, I would emphasize these two characteristics here. Two pairs of congruent sides, two pairs of parallel sides. Then we have our rhombus, and do you see how I have added AKA parallelogram? Remember in your last slide we said that all you really needed to have to be a parallelogram was opposite sides congruent, opposite sides parallel. Well, the rhombus has opposite sides congruent and opposite sides parallel. It's a specific parallelogram that also has all four sides congruent. So not all parallelograms are rhombuses, but all rhombuses can also be classified as a parallelogram. It's a unique parallelogram that has all four sides congruent. And again, most of them, the traditional rhombus that we see here is made up or does include two acute angles that are opposite each other and congruent, and two obtuse angles that are opposite each other and also congruent. Next, we're going to talk about our square. So our square is our quadrilateral that has four congruent sides. That sounds familiar. We just talked about a shape that has four congruent sides. Two pairs of parallel sides. Opposite sides are parallel. They're also congruent to each other. And then it is also made up of four right angles. I've seen some of this criteria before. I've seen two pairs of parallel sides in our parallelogram. I've seen four congruent sides. That was also the case with our rhombuses or our rhombi, and we want to talk in terms of plural words. But the square, unlike most rhombuses and most parallelograms, also has 90-degree angles. So you see this AKA, also known as a rhombus, because it's like a rhombus that is no longer slanted to the side, it's set and straight up with all four sides congruent. A parallelogram, because all you really have to be a parallelogram is four sides, opposite sides parallel, opposite sides congruent. The square certainly has that. And then we haven't touched on the rectangle yet, but we'll talk about how to be a rectangle. You have to have 90-degree angles, and our square also has 90-degree angles. So we're kind of breaking the mold for our traditional, or in our traditional thinking as far as quadrilaterals are concerned, and really focusing today on the fact that based on their definition, a square could also be a rhombus. It could also be a parallelogram. It could also be called a rectangle. But I do want to emphasize that not all rhombuses are squares, because not all rhombuses have 90-degree angles. Certainly not all our parallelograms are squares, and we are familiar with rectangles that are not squares at all. And then, speaking of rectangle, here's our rectangle. To be a rectangle, you need to have two pairs of congruent sides. I've heard that before. Two pairs of parallel sides. So we've got a parallelogram here. But to be a rectangle, you have to have 4 right angles. So it's like a parallelogram that's no longer slanted, it's standing right up. So if we just look at this technical definition of a rectangle, two sides opposite each other that are congruent, two pairs of parallel sides, and 4 right angles, a rectangle can also be classified as a parallelogram. Don't want to confuse you, but I do want to mention that it is not a rhombus because not all sides have to be congruent. Rectangles are not all of them are not squares because, again, all sides are not congruent. It just has to have those 90-degree angles in order to be a rectangle. And then we have our trapezoid. Please excuse some of my art on there. Trapezoid, everyone kind of has that odd family member that doesn't quite fit in. So he doesn't fit in with the parallelograms. Remember, so far, you can be a rhombus and be a parallelogram. You can be a square and be a parallelogram. You could be a rectangle and be a parallelogram. Well, you cannot be a trapezoid and be a parallelogram. All you have to be a trapezoid is one pair of parallel sides. You have to have that one pair of parallel sides. So what I've highlighted in blue, those are my parallel sides. Notice the sides that are emphasized in yellow are not parallel to each other. And that's why we end up with a shape like this and not a rectangle or another parallelogram. Now in red over here, I drew another example of a trapezoid. These two sides are parallel to each other. The reason I squiggled this out, one pair of congruent sides, because you don't have to have one pair of congruent sides. That's a unique trapezoid, which we'll talk about in just a bit. Really all you need is just that one pair of parallel sides. So here's an example of a trapezoid that does not have one pair of congruent sides, yet it's still a trapezoid. And here's some better pictures of it. This is like the triangle or trapezoid, that we have here. And here is our traditional trapezoid. It's called isosceles trapezoid because, as you can see, just like an isosceles triangle, those two sides are congruent. Well, let's look into our trapezoid notes a little deeper. To be a trapezoid, you have to have one pair of parallel sides. So the bases of the trapezoid are those two parallel sides. And here are these two red lines emphasize the two bases of this trapezoid. The legs of the trapezoid are either of the two sides that connect the bases. If it's an isosceles trapezoid, which we'll talk about in just a bit, the legs are congruent, but not all trapezoids have to have that. Here's our isosceles trapezoid. An isosceles trapezoid is a trapezoid with congruent legs. And of course, congruent means same shape, same size. And then, finally, we're going to talk about our last quadrilateral, the kite. Looks a lot like our traditional kite that you might fly in the spring or the fall. But a kite is a quadrilateral with two pairs of, this is an important buzzword, adjacent sides that are congruent. Adjacent means side by side. So this side is side by side. It's connected at a point with the other, and they are also congruent. These two bottom legs are connected at a point. They're side by side, and they are congruent not to the other two, but to each other. Adjacent sides touch or meet. They share an endpoint. And this just emphasizes the congruent pairs of sides in this kite. And then our last bit of information for today's notes says the following: the sum, that's the answer you get when you add them all values together, of the measures of all of the interior angles, the angles on the inside of a quadrilateral, will always add up to 360 degrees, no matter what kind of quadrilateral it is. We're going to talk about that a little bit later, probably into next week. But this concludes your notes on quadrilaterals. I'd like for you to practice this skill just a little bit further by completing the 8 questions on page 14 in your quadrilateral congruency booklet. Look forward to seeing you all tomorrow. Have a good afternoon.